All right, guys, we are recording. Okay, there will be homework from today. It'll be due next week, like normal. So, but today we're going to kind of touch on some ration formulation, making premix, and then adding medicated feed to diets and premix. So, in essence, a type A medicated feed is the concentrated drug. So like it'd be Rumensin 90, for example, which would have 90 pounds of Rumensin per pound, or 90 grams of Rumensin per pound of product. Okay, type B is whenever I take a type A and I mix it into something like a premix. So we're not going to feed that directly to animals. And then type C medicated feed is you take a type B and you add it to the feed. Type C medicated feed is what will actually be delivering the drug to the animal. Okay. So if I'm adding Rumensin to a free choice mineral, is that a type A, B, or C medicated feed? They kind of unpack it. Say we made a mineral, has Rumensin in it, and we're giving it to those cattle free choice. Is that a type A, type B, or type C? Type C. It's directly being fed to the animal. Okay, so type A is the concentrated drug form. Type B is like a premix. We take that concentrated drug form, we dilute it out. Cannot feed a type B medicated feed to animals. Okay. Type C, we take a type B, we add it to the complete ration, and that's what can actually be delivered. Okay.
So you can't feed type B.
Cannot feed type B directly. Okay. So we're going to talk about how to make a type B feed to deliver the drug at a legal dose. Okay. All right, first we're going to talk about using units to solve your problems, okay? So you guys call it train tracks is the Common Core thing, I think. Common Core math, okay? But it's dimensional analysis, okay? So how can we set up our problems to where units cancel out and you're left with the units that you want? Okay, it's going to be very important for calculating inclusions of a different medication or feed additive in a diet, and then also what that concentration needs to be for type B medication. Okay, so for example, like you would have had in your math or your math part of your exam, we can use this to go do something as simple as going from as-fed to dry matter. Okay, so if we have a $200 per ton as-fed, 200 ton A, F, okay, as fed. The supplement is 90% dry matter. Would I multiply or divide by 90% to figure out what this is going to cost on a dollar per pound basis, dollar per pound dry matter basis? Okay, so 90% dry matter is 90 pounds of dry matter divided by 100 pounds as fed. So if you think about this, think about it like that. Now you can see how you arrange this to cancel out as fed on the bottom and be left with the units you want, right? That makes sense? I myself don't memorize whether I'm going to multiply or divide by a percent dry matter. I'm going to as fed dry matter. I will work it out like this. Maybe it's done in my head, but this is how I break this out always, and it avoids mistakes. Make sense? It builds kind of checks and balances. Okay, so let's work this out real fast. $200 for 2,000 pound as fed. So here we have 100 pounds as fed, AF, for 90 pounds dry matter. Okay, that cancels out. So we're left with dollars per pounds. Who wants to punch that in? The calculator. Okay. Does this make sense? We're going to look at some much more complicated examples. You guys will need to do these types of examples in next exam 3. Okay. Okay, so that just shows you how to arrange it. Okay. We can also use this for math that we use in exam 2. If we're going from how many cows or how many steers can we graze? If we have historically grazed 30 1,200-pound cows for 300 days a year. Okay, so this was the math that was on exam last year, right? I changed it up just a little bit for you guys this year. So you can use this dimensional analysis to make sure that this is going to be correct as well. Sorry for those watching the recording, but I'm drawing on the whiteboard. You won't see this. Okay. Okay, so our historical animal unit days, okay, so we have 30 cows times 1,200 pounds per cow, and there's 1 animal unit for 1,000 pounds, okay, and we have 300 days. So, you cancel out your units, cows cancel out, pounds cancel out, you are left with animal unit days, okay? So, historically, we had 10,800 animal unit days. So how many animal unit days is 1 steer? 750 pounds per steer. There's 1 animal unit is 1,000 pounds. We want to graze them for 140 days. So that is 105 animal unit days is represented by 1 steer. How many steers can we run? We need the animal unit days to cancel out. So 10,800 divided by 105. We can run 102 steers under this scenario. Does that make sense? So if you guys can figure out how to do dimensional analysis, 95% of everyday math that you will need to know for the rest of your life, you can do without memorizing equations. Okay? Does everybody agree with that? Okay. Okay. So now we can use it to solve our math problems. We wanted to know how much Rumensin 90 I need to include to feed 350 milligrams per day. Okay, 350 milligrams of Maninsin a day. Okay, things that I will give you will be Rumensin 90 is 90.7 grams of Maninsin per pound of Rumensin 90. I won't expect you to memorize the concentration of the active ingredient in the type A medication. Okay, so Rumensin 90 is an example of a type A medication. Does that make sense? It's the concentrated form of the drug. Yeah. So Rumensin 90 is 90.7 grams of Maninsin per pound of Rumensin 90. And I'll give you what cattle will eat. Okay. They will eat on average 20 pounds of dry matter per head per day. Okay. So what do I know? 350 milligrams per head per day is our target. Would I want to divide or multiply by 20 to get pounds of Maninsin per pound of dry matter? I need to cancel out head days and I need pounds of dry matter on the denominator, right? So what would I do? Divide. Okay. Everybody understanding the points I'm trying to make? Okay. Okay. So I need to include Rumensin 90 at an inclusion that'll bring 17.5 milligrams of Rumensin per pound of diet right. Okay. So I can calculate how many pounds of Rumensin 90 I need to add to the total diet in a type C medicated feed. Okay, so 17.5. We know that there's 90.7 grams of Rumensin per pound of Rumensin 90. So 17.5 divided by 90.7. Well, that's grams and not milligrams. So we know that there's 1,000 milligrams in a gram. Okay, so 17.5 divided by 90.7 divided by 1,000 milligrams of Rumensin, okay, per gram of Rumensin. So that leaves us with grams of Rumensin 90, or no, excuse me, pounds of Rumensin 90 on the numerator, and then pounds of diet dry matter on the denominator. Okay, so we would need to include Rumensin 90 at 0.0193% of diet dry. Does that make sense? To bring in 17.5 milligrams of Rumensin per pound of diet dry. Okay. So, what if we want to go from or figure out how much Rumensin 90 we need to add in to make our type B medicated feed, or vitamin mineral premix, which will actually be what we're load into the mixer to deliver that feed additive. Okay. Would I divide? So if I have a ration that's formulated to have a 3% of dry matter vitamin mineral premix, would I multiply or divide by 0.03? Divide. Yeah. So that is 0.03 pounds of premix per pound of diet dry. So I need to divide by 0.03. Okay. So the premix, this type B medicated feed, would need to be 0.64% Rumensin 90. Everybody follow that? So Rumensin or Rumensin is just one example of many different classes of feed additives we may feed. But if I give you Experior 240, and I tell you that it's 240 grams of glubabergon per ton of dry matter is your type or type A medicated feed, you can do the same exact math. I don't remember exactly if it's 100% correct. I think it is. You can do that same math to figure out what your inclusion of that type A needs to be in your type B. That make sense? Okay. What is type A medicated feed? Type A medicated feed is what? What is type A medicated feed? Oh, I didn't point to you. Yeah. Do you remember? So type A medicated feed is so it'd be the concentrated, the active ingredient will be concentrated. It's what we use to make our type B medicated feed. So what is a type example of a type B medicated feed? Anybody collaborate?
Watering down something or like mixed with something else.
Yep. Can we feed it to an animal? No. Yeah. So type B would be the active, the medicated premix. Okay. And so type C, Reagan.
It's where you're taking type B and mixing it into the ration.
Okay, so we can feed it directly to the animal. Okay. Important things. Okay. Premixes. I know you guys talked about these in a lab in Feeds and Feeding. If you took Feeds and Feeding. Maybe one or two have not or are taking it now. But premixes, we formulate these to provide supplemental vitamins, minerals, feed additives, and any other ingredient that would be typically low inclusion. So quite often we'll have producers include their urea in their premix. Okay? So urea as a source of non-protein nitrogen. Okay? Feed premixes can be dry or in suspended liquids. Okay? Most feedlot consulting nutritionists are actually in the business of selling premixes. Okay? This is the model that PMS Midwest, which represents about 40% or more cattle on feed. So their clientele feed 40% or more. It's kind of nebulous. They don't tell you directly. But PMS Midwest represents a large proportion of cattle on feed. It's the model they take. Cargo Animal Nutrition, another example. Westway, Livestock Nutrition Council, even, they will have nutritionists on staff that provide consulting services, but the way they bill typically is based off of premix sales. Okay? So, usually they could offer maybe a penny per head per day charge, but it will typically pencil out for the producer to go the premix route. And so the consulting nutritionist will add some level of fee. X percent of premix sales will go to their pocket, X percent will go to the mill, etc. Okay. So I always thought that was interesting, not something they ever taught me in undergrad. Dry premixes, we want to formulate these somewhere in the range of 2 to 5% of diet dry matter. Why would we not want to formulate something at 0.5% of dry matter or 1%? I think it says in the slide. Not that part of the slide. Okay. So, okay, let's say I have a feed truck that has a 30,000 pound capacity. Okay. If I had a premix that was 1%, what's 1% of 30,000? Can't do that in my head. I should. It's like 300, maybe 300. Yeah, 1% of 30,000. 300. Would I expect an ingredient to be loaded in, 300 pounds of this ingredient to be loaded into this 30,000 pound load and expect that it would be evenly distributed throughout the feed when it gets mixed? Okay. So that is why we use premixes, and we will do it somewhere 2 to 5%. Commercial lots, commercial feed yards, they're more in the 2 to 3% of diet dry matter. They do that because lower inclusions mean they're feeding less of it, meaning they have to ship less of it, so it cuts down on shipping costs. So if we formulate a ration and we see I need to add limestone, cobalt, copper, zinc, selenium, XYZ, okay, and it adds up to that total amount of things that we added only add up to 1%, we would add a carrier. So we would add about 2% of like a DDG or soybean hulls or wheat midds, some other ingredient that we don't really necessarily care if it's bringing a nutritive value. We just want to create bulk in that mineral so that we can have our target inclusion level, so that we can feel more comfortable that it's going to be evenly mixed and distributed through that feed. Okay? Does anybody remember that? Talking about that in feeds and feeding? Ish. Okay. All right. Now, there is, other than dry premixes or even suspended premixes, there's kind of another way that I would say is relatively new, and they're called micro machines. So these micro machines will have 6 bays where you can have different additives, and 6 bays or 12 where you have up to 12 different ingredients in a bay. And this micro machine will dispense whatever you're adding to your mineral, limestone, your vitamin A, D, and E, your beta agonist or ligands is what they call them now. Your MGA for heifers, okay? They'll dispense that. That'll get dissolved in water, okay? And then that water gets added to the ration with all the products, okay? So, 2 main benefits. It allows you to package typically low inclusion ingredients at precision levels. Okay, so it has a very fine scale that it's measuring these out with certainty that it'll blend throughout the wider ration. Okay. In essence, you can add that liquid that has all the suspensions of the vitamin minerals that you want into the ration at a lower inclusion level, but since it's suspended in liquid, you have more confidence that it's going to be evenly distributed when it's mixed. Okay. So one of the good benefits of that is you can change that formulation for your vitamin mineral premix for each ration that you're feeding. So you don't have to feed one common premix, right? You can also change it over time, how much this liquid through your micro machine, you can change it over time to where you're precisely formulating how much of these additives you're bringing in based off of the average animal intake of the whole yard, right? So as animals get heavier, they eat more. So to achieve a given threshold of a feed additive, you can get away with a lower inclusion, right? Does that make sense? Okay, if I want to bring 330 milligrams of monensin per head per day, the concentration of rumensin 90 will need to be higher if an animal's eating 15 pounds a day as opposed to 20. Okay? So it builds some flexibility and allows you to fluctuate how much of these ingredients, these micro ingredients, you're feeding over time. Okay? So things that they'll include in a micro machine: trace vitamin mineral pack, hyaline, ionophores, so like rumensin. Your vitamin A and D will typically be fed or contained together within a bay. Vitamin E will be in its own bay, and then a beta ligand, which is a beta agonist, okay, which we'll talk more about this next week. Okay. So these things are obviously cost a lot of money. The typical model that is used is a micro machine as a company will own the unit and they will lease it out to the feedlot. Okay. And that feedlot will pay them a leasing fee of I don't know how much. Okay. They will typically pencil out. The larger ones will typically pencil out if you have an 8,000 to 10,000 head capacity feed yard. The small ones, which are kind of newer, they'll pencil out at a smaller feedlot capacity, so about 5,500. Okay, so that small one penciling out for a 5,500 head feed yard will be dependent on if that operation has space for it, right? And they don't have to build a new building. Obviously, that added infrastructure is going to add costs. So if they have to add a new building, maybe they need a larger feedlot to make it make sense. Okay. So here's a video. I think it's pretty loud. But bays will sit on either side of this auger. It'll open one gate, dispense out the whatever is contained in that given bay. Then that auger will dispense into this chamber where it will be diluted into water. And then that water gets pumped out into the either stationary or whatever mixer wagon they're using. Okay? Does that make sense? Cool. Okay. All right, rumensin. This, we'll talk more about this on Thursday. Okay. Actually, I won't. Kyle's going to teach you guys. Hopefully, he does a good job. I'm going to Brazil tomorrow. So, hopefully, you guys, I'll be back Monday. So, if you guys have questions about the homework, we can, what?
If we have questions about our project, we study it, we just refer to
Yep. When is that due?
it.
Oh, this Friday? Okay. Who started? You started? Hey, that's great. No one else has started. Yep. All right. I guess I remember being a senior in college too. So, if we need to be flexible and when that stuff gets turned in, just let me know. But let's try to have it done Friday. Okay. All right. Rumensin. So this is the trade name for Maninsin. Okay, Maninsin sodium. It is labeled to be fed to increase feed efficiency in forage and finishing diets. Okay. Rumensin 90 is the type A medicated feed. It contains 90.7 grams of maninsin per pound. Okay. Maninsin is an ionophore. Ionophores are technically antibiotics. Okay. However, it is not humanly medically important. It's not an antibiotic that is used for human medicine. So it does not require a VFD, veterinary feed directive, to feed it. Okay? So, maninsin, we'll talk more about this and its modes of actions tomorrow, but maninsin is an ionophore, targets gram-positive bacteria, okay, within the rumen. So it kills gram-positive bacteria. Whenever it kills those gram-positive bacteria, it allows gram-negative bacteria to proliferate. These gram-negative bacteria are more, they produce more propionate. Gram-positive bacteria produce more acetate. So if we kill gram-positive, we reduce acetate production, we increase propionate production. Okay? Propionate is more energetically efficient to the animal. Okay? So it improves feed efficiency. Classically, in high roughage diets, the greater propionate will increase average daily gain, okay, but it will not change dry matter intake. Can anyone explain why that would be? We'll talk more about this tomorrow, okay? In a high forage diet, propionate will increase when feeding maninsin. Average daily gain will increase, but dry matter intake will stay unchanged. Can anybody guess why? Okay. I'll just go ahead and say the next part. High concentrate diets will have feeding maninsin to high concentrate diets will increase propionate. It will actually decrease feed intake, but average daily gain won't change. Okay. So it all has to do with how intake is regulated. We'll talk more about this on Tuesday, but this will be on your exam 3, explaining this. Okay, so here, this could be TDN, this could be NEM, this could be dry matter digestibility, okay, on your x-axis. Here on your y, we have dry matter, okay? As TDN, NEM, dry matter digestibility increases, forage or intake will increase, okay, up to a point. And then you actually start seeing it reducing intake. Okay. Does anybody have a guess as to why this response would happen? So there's a lot of debate in the literature about intake regulation. What is truly regulating intake, right? Could be hepatic, so liver oxidation, as one mode of intake regulation. Okay, cattle will eat up until their liver oxidizes so much fuel. Okay, the classic response is explained in the biphasic regulation of intake. At lower quality diets, so think high forage, pasture-based diets, what is going to regulate how much an animal can eat? So in higher forage diets, and low quality diets, what do you think would regulate how much an animal will eat? I wouldn't want to use digestibility when we have that term. Yes, right. But that plays a role as why as digestibility increases, intake will increase. So that plays another role, and those two would be related, right? Definitely plays a role, which would impact the digestibility of the diet. All good stuff. I'll go ahead and tell you, gastrointestinal fill. So they'll eat until they feel the mechanical sensors in the rumen begin to be distended. Okay. So think about, would you stop eating salad? Not just because it sucks, but would you stop eating salad because you have high blood sugar? No. You could eat salad if you like that to a point where you start feeling full, right? So it's gastrointestinal fill, okay? So ruminal fill. Okay, so by feeding Meninsin, we haven't switched how the intake regulation if we're feeding ruminants into forage-based diets. Okay, they will still eat until they see that mechanical fill. Okay, however, we're increasing propionate, which is more energetically favorable. So we will see an increase in average daily gain without a change in dry matter intake. So in a high forage diet, Meninsin will cause forage intake will remain the same, okay? But average daily gain will increase because propionate is more energetically favorable, okay? So at some point, I don't remember the exact number, but I have it in the slides tomorrow, it switches to a chemostatic. So this, think blood sugar, right? Ice cream. You guys will eat ice cream not until you feel gut filled. Maybe most of you guys wouldn't, right? But you're going to eat it until you start feeling sick because you have such high blood sugar, right? So you experience malaise, which is kind of ill feeling because of how much blood sugar you have. So in cattle, the most classic blood regulation thing that's been proposed is propionate. Okay, so higher concentrate diets, they will eat until they achieve some level of propionate concentration in their blood. Okay, so when we feed ionophores to cattle in a high concentrate diet, okay, propionate will increase, so they will achieve that threshold at a lower dry matter intake, and they'll stop eating sooner than they would without Meninsin. Does that make sense? Okay, so they eat less, so they gain. So they eat less, but gain does not change because they're still producing that same amount of propionate, right? Just being achieved at a lower level of intake. So decrease intake, increase average daily gain, you've still improved feed efficiency. So be able to explain that in exam 3. We'll talk about it more tomorrow. Any questions on that? Okay. All right. So in a feed yard, Meninsin inclusion is limited to 5 to 40 grams per ton on a dry matter percent. So on a 90% dry matter percent. So on a full dry matter percent, it's 5.55 to 44.44 grams per ton.
Why is it such a
They want to build flexibility, I guess. Yeah. Yep. They also have a limit where you can't feed less than 50 milligrams per head per day. And the upper limit is 480 milligrams per head per day of monensin. Okay. Most people in the feeding world are somewhere around 300 to 400 milligrams per head per day. There at Bushland, the feed research feedlot I used to work at, we always try to be around 330 milligrams per head per day on monensin. Okay. Growing cattle on pasture, the limit is 200 milligrams per head per day. Okay. I'm not sure why you can get away with feeding more to cattle in confinement than you can to cattle on pasture. I don't know why, but those are the FDA rules. Okay. So let's look at this scenario. Okay. So if we went on a based on dry matter inclusion limit, so let's just feed the maximum amount of rumensin 90 to provide 44.44 grams of monensin per ton of dry matter. Okay. This scenario, we have an initial body weight of 750 pounds. We have a final body weight of 1,500 pounds. So on average, over the entire feeding period, that animal weighed 1,125 pounds. Okay. We assume they're going to eat 2% of their body weight. Okay. Dry matter intake will be 22.5 pounds per day on average across the whole feeding period. So how much monensin is this animal eating on average across the whole feeding period? So what do we need to do first? The question is, how many milligrams of monensin will that animal eat per day on average across the whole feeding period? So 44.44 divided by what? How many pounds?
2,000
Okay.
pounds.
So divided by 2,000. Okay, Ben, what do we got there? Ben or Ben? Ben. Okay. So what is that? 0.0. Oh, I can do 2. Oh, that's grams. Multiply that by 100 or 1,000, excuse me. Or
I guess, yeah.
okay, it's milligrams. Okay. So this ration contains 22.22 milligrams of monensin per ton of dry. No, per pound of dry. Yeah. So 22.22 times 22.5. Okay. So how much is that animal eating?
For 500 milligrams.
500 milligrams of monensin on average across the whole feeding period. Are we legal? The legal limit was 480. We are illegal. Okay. What about at the beginning of the feeding period? So 750 times 0.02. So we are right in the sweet spot, 330 milligrams per head per day. So can you see the benefit of feeding a micro machine or using a micro machine? You can change how much rumensin 90 you're providing in the diet as that animal gets bigger and he's eating. We went from being illegal at the start to being right spot on, or excuse me, illegal on average, being right spot on at the beginning. All right, so that's an advantage of the micro machine.
How does stuff like that get called? Like, what would the consequence of that be?
So
Or would it, work better?
there's The FDA limits are based off of studies that have shown, okay, if I feed a little bit more, will we continue to see an increase in feed efficiency? You don't really. So a cost would be that producer wasted money. Another cost would be if the FDA found out those animals are technically adulterated and aren't supposed to enter the food chain. Do you think the FDA is going around and assessing this?
Yeah, I don't
No. Chances are no one would know.
Or I guess that's what I'm getting at. Is there any way it could be tested, like just like a regular withdrawal period and all? Okay, so it's kind of
No. Yep.
that's what I was getting at. I didn't know what kind of trouble it could.
Now, if they found out and they found you criminally liable, you can go to federal prison. Yeah. So that's not worth it to most people. Also, most people are feeding 100 milligrams per head per day less than the legal limit because they don't see a benefit of spending more money on Rumensin as opposed to what 300 to 350 milligrams will do. Does that make sense?
Yes.
Yeah. So what's driving people to be legal on Rumensin is typically they don't want to waste money. Good question, though. Okay. All right. Let's look at 300 grams of Rumensin per ton of dry matter. Okay. Or not 300, 30. So what's 30 divided by 2,000? Times 1,000. Okay, so 15 milligrams per pound times 22.5. 337.5. It's like I went before and made sure that it would work out. Okay. So if we feed 30 grams of Rumensin per ton of dry matter, on average, we'll be feeding 337 grams of Rumensin or milligrams of Rumensin per day. Okay. So on average, we're legal. What about the end of the feed period? What do we say, 15 milligrams per pound? So 1,500 times 0.02. 450. So we're on the upper threshold where that feeding over is not necessarily advantageous. We're probably wasting money, but we're legal. Okay. That is what most people that don't have a micro machine will do, is they will make a tightly medicated feed or buy a tightly medicated feed that provides Rumensin for their group of cattle so that group of cattle will consume their target Rumensin amounts per head per day over the average of the feeding period. So at the start of the feeding period where intakes are lower, they're eating less Rumensin than what would be beneficial. At the end of the feeding period, they're feeding more Rumensin than what would be beneficial. Okay, so you kind of have a opportunity loss on both ends by not having a micro machine. That make sense? But most people with small feedlots that don't have a micro machine, that's what they'll do. Okay. Rumensin and mineral inclusion. So this would be making our tightly medicated feed. So when we're formulating a ration using the calculator, what you're going to have to do for this, you're going to have to formulate the ration. You're going to have to delete out your non-premixed ingredients. Okay. Then you're going to take the nutrient profile that's provided for those non-nutritive, so the nutrient profile of your vitamin mineral premix. You're going to copy it into your feed library. You're going to name it Ben's premix, okay, in the feed library. Then you're going to reformulate that diet with your formulated premix. Okay. You're going to turn in those two copies. One copy of your calculator is going to be where you make the premix. The other copy is going to be your final ration. So I think I have two problems. We're going to have to turn in 4 calculators. Okay. So we'll go through some examples, but I typically start with the non-vitamin mineral premixes, so the major ingredients, so the ingredients, not premixes. So the premixed ingredients. So things that I know, the ingredients I know will be included in that ration. So steamed flake corn, DDGs, roughage, etc. Okay. Then I'm going to start in on calcium and phosphorus. So I'm going to make sure my C/F ratio is fine. Chances are I'm going to have to add about 1% to 1.5% of diet dry matter as limestone. Okay. Always do this on a percent basis, percent of dry matter basis. So before, when we were doing supplements to grazing cattle, I said it was easier to do it on a pound of dry matter intake basis. This is much easier to do on a percent of dry matter basis. Okay. After you formulated your full ration, I'm going to say you delete out the ingredients that you don't want left in your premix. What's going to be left is, as long as those ratios of those micro ingredients don't change, what's going to be left is the ingredients that's going to compose your premix. So then I would add Rumensin 90 or whatever other feed additives we want to bring in. Okay. You will have to calculate the inclusions of these by hand. No real easy way to do it in the calculator. So you're going to calculate these inclusions by hand. So for example, if calculator tells me that this animal is predicted to eat 22.5 pounds of dry matter intake per day, and I want to feed 330 milligrams of Meninsin per head per day, so 330 milligrams of Meninsin divided by 22.5, I would need to provide 14.7 milligrams of Meninsin per pound of diet dry matter. 14.7 divided by 90,700. As Rumensin 90 has 90.7 grams per pound. So that means it has 90,700 milligrams per pound. So I'll need to add 0.000162 pounds of Rumensin 90 per pound of diet dry matter. Multiply that by 100. So Rumensin 90 would need to be added to that vitamin mineral or to that ration at 0.01621%. Okay. Then, if let's say the assignment tells you I want you to formulate a 3% premix inclusion, you're going to take the sum of those micro ingredients, and then 3% minus the sum of those micro ingredients will tell you how much your carrier to add. So that carrier could be distiller trains, for example. Okay, so you'll add that in there. Next, you take that nutrient characteristics and mineral contents of the feed from that feed list or from the calculator sheet, copy it over into your feed library, and now you have formulated your premix. So you can name it ANSC 408 premix or whatever you like. Okay. Then you can go back in, reformulate your original ration, and then call that feed list item your vitamin mineral premix at 3% inclusion, and it should be all good. Does that make sense? Probably not. So we'll run through an example. Okay. Okay. All right. So open up calculator. If you want to follow along, I'm not going to make you. I'll go ahead and have 2 of these open at once. It's much easier if you can have 2 of the calculator programs open at once. Okay. All right. The scenario on the slide says we purchased these animals at $750. We want to finish them at $1,500. I don't know if I specify that. Let's just make it 1,500. Then we're going to feed them for 200 days. That means that these animals should gain 3 pounds and 75. Our desired average daily gain will be 3 pounds and 3.75 pounds per day. Okay. Okay. So I want the base ration to be somewhere between 60 and 75% steam plate corn. I want some kind of a byproduct included at 10 to 20%. So that could be corn gluten feed, could be sweet bran, could be distillers grains. Okay. I'm going to say we're going to add urea at 1 to 1.5% of diet dry matter. We're going to add fat at 1 to 3% of diet dry matter. And then the roughage, we're going to feed somewhere around 8 to 15% of diet. Okay. So goals are to keep crude protein below 15%. Even at 15%, we're going to be overfeeding crude protein, but the typical feedlot ration today is somewhere around 13 to 14%. Okay. And then keep fat below 6% of diet dry matter. NEM, we're targeting somewhere 95 to 100 megacalories per hundredweight. Okay. As you formulate rations, you will just kind of know these targets offhand, right? They're going to become more natural to you. Also, it's going to become more natural to you on where to start out with these. Okay. So, got all my animal information in here. Let's go to the balancer. I start out with our highest inclusion first. Concentrate, steam plate corn. I'm just going to start out at 60%. Okay. So now, before I wanted this cell to equal this cell to equal this cell. Now I want this cell to add up to 100. Okay. Right now it's at 60. I want this to be 100. So this cell is the sum of all these. Does that make sense? But this cell where I'm specifying the feed intake needs to equal our predicted feed intake so that our feed intake ratio is 1. Everybody following? Okay. All right, next, what byproduct do we want to use, guys? Okay. So this cell here is the sum of all these. We're formulating on a percent of dry matter basis. So this cell needs to add up to 100. Okay. But our feed intake cell, where we specify how much that animal's going to eat, needs to match our predicted intake. Okay. All right. Who wants to shout out a corn milling byproduct? That's not corn milling byproduct.
Yeah.
You guys want to do dry distillers?
Yeah.
Okay. We'll do corn. Let's just start out at 15%. Next, I'm actually going to skip this. We're going to go to our roughage, harvested forage. Let's do. Let's do wheat pay. Let's go 8%. Fat. So I added in corn oil. Okay, I'm going to start out at 3%. Okay. Next, let's go urea. Nope. I think I put it under commercial feeds.
It's in concentrate.
It is. There it is. Let's just do 1%. Okay. So our CA to P ratio is 0.1. Do we think we're gonna have to add in a lot of limestone? Okay, let's start with that. I'm gonna start out with 1.5%. Okay, that got us to 2. Keep in mind, as you add things in, that's gonna decrease a little, right? As you're bringing in other ingredients that aren't calcium. Okay, sodium. So how do we bring in sodium? How do we bring in sodium? Salt, bingo. Sodium chloride, I don't know, 0.2. Okay, it says we're adequate there. We're gonna have to add potassium, cobalt, copper, manganese, and zinc. We're gonna run out of lines.
If you run out of lines, what do you do?
I'll show you. You kind of have to delete some other ingredients. Mainly, I start with things like urea, and then I start with, after urea, I'll go to corn oil, because those are ingredients that aren't bringing in minerals. They're just bringing in protein and energy. So I won't start looking at the NEM values until I have my premix made, typically. Does that make sense? Okay. I mean, you could start looking at it now. Right now, we're at 1.01 NEM. So I know that if I delete corn oil, I'm probably going to be within that 95 to 100. Does that make sense, guys? There's just no better way of doing this with these programs that we have freely available.
So on our homework, some things and then.
Probably will. Yeah, start out with urea and then move to corn oil. Okay. So we start do our potassium. Okay, 0.1 got us there. Cobalt's only moderately deficient, or like minorly deficient. So next I'm going to go with, let's do copper. Copper sulfate. Okay, copper sulfate, we need to bring in 7 ppm. So that's a part per million. So I'm going to always start out with 0.005. Just a little deficient. So let's bump that up to 7.5. Still deficient. Let's go 0.00. Still deficient. 1.5. Still deficient. 0.003. Oh, I was looking at the wrong one. We're way deficient. Okay. So 0.05% copper sulfate got us there. Cobalt. Cobalt can be very, very small. That made us. Okay, so 0.1, 2, 3, 4 zeros and 5 got us there. Now I'm out of lines. Okay. I know my NEM is a little high. See what this does. 2.5 gets me to an NEM of 1. So I'm going to remember this, and I'm going to come over here to my other ration formulator. Make sure that these are all entered the same. 15, 13. Okay. Balancer. Actually. Just copy those in. to your other sheet. Okay. I'm going to delete out urea. Now let's bring in zinc. Okay, 0.0015 got us there. Okay. I am adequate in all these. My NEM is a little high, but remember, it's going to get diluted a little bit with urea, and we can do some fine tuning after we formulate our premix. Okay. So now I can delete these ingredients out. Okay. And I'm just left with 1.9 here. So that means all of these added to 1.9% of the diet dry matter. So did I say what I wanted the premix to be? No, I didn't. Let's say we're going to do it for a 3% diet dry matter premix. Here's when I'll add in my Rumensin, which I think I put under commercial feeds. So there's Rumensin 90. On the previous slide, we calculated that we needed to bring in 0.01621. Okay. The sum of all these cells is 1.87. So 3 minus 1.87 is 1.13. So I'm going to use a carrier, distiller's grains. I'm going to plug in 1.13. Now this sums up to 3, so I know that's going to be a 3% diet dry matter inclusion premix. Okay. This premix is going to have these nutrient specs. Does that make sense? Everybody follow what I did? Okay. We'll go through one more example. Okay. Yes. Question?
For the homework for question number 1, it doesn't say include Monday.
Yeah, that's Rumensin 90.
Okay.
Yep.
You should look for next tonight.
Yeah, Rumensin 90 is the type A. Okay. So, go over here to your other sheet. Come here to feed list. To minerals and vitamins. So let's make number 133 practice example. Okay. So I'm creating a new feed ingredient called practice example. Now I'm just going to take these values that are recorded here in this column and enter it into this other column. Okay. All right. Don't care about unit cost. Dry matter percent is 96. So I got that from this cell here, right? My premix is 96% dry matter. You see that? Protein, free protein 11.7. Not going to worry about RDP. TDN is 30. It goes ahead and calculates ME and NEM. NDF is 13. EENDF is 3. Fat is 4.1. Calcium is 19.75. Phosphorus 0.42. Sodium is 2.62. Potassium is 2.2. Magnesium is 0.22. Sulfur 0.26. Cobalt 3.65 ppm, copper, 439.6, iron, 332.3, manganese, 151.2, selenium, 0.22, zinc, 224.9. Okay. Everybody see where I got these information? Other than dry matter percent, they're all in okay, this column. Okay. We follow? Ish. Okay. So I have this other sheet list set or open. I'm just going to take this, which I entered over here, and paste it into here. What it won't let you do is paste over the N. So we'll go up to TDN. Okay. Pop over on the other side of NEG. I can just hit Control Shift and then the right arrow and jump all the way over there. We'll paste those values there. Okay. So I have now added my vitamin mineral premix into my feed library. Okay. Which I copied and pasted our macro ingredients into already. Oh, I guess what I entered was already in my ration formulator, which I had already copied and pasted our macro ingredients into. Okay. So all these say deficient. If we did everything right, and go over here, minerals and vitamins, fingers crossed, guys, drum roll, okay, and add a 3% here, we're all adequate, except for manganese. I'm probably, if you guys get to this point and you have one thing that's off, I'm probably going to count it okay.
Fairly off.
Yeah. 19.9 versus 40. Actuality should probably go back in and re-enter it, but I'm not going to worry about it. Oh, wait. So here, why doesn't it set up to 100? Because 15, I didn't get it up to 100. So now I'll start playing around with this to get my NEM, NEG right, my crude protein right. I need to go up another 5%. Okay. Make sure this matches up, 21.9. My NEM is 1. My crude protein is between 13. What did I say it would be? Oh, less than 15%. So we're at 14.7. Call that good. All this adds up to 100. My feed intake ratio is 1. And C to P ratio is above 1.5. Okay. I'm going to say that this is negligibly different in potassium. I don't feel like going back and redoing it for this manganese. So, any questions? Did everybody follow? Does this make sense? Is it difficult? Kind of the easiest way to make a type B mitigator when you have an Excel-based program. Okay, let's go back to the slides. And I think we have another example in here. What time is lab in? 3? Okay. Okay. So, beta ligands. You guys may have heard them referred to as beta agonists. However, the newest one, Experior is both an agonist and an antagonist. So the more correct term is ligand. Okay. Both of the major ones that are used in the beef industry today are sold by Elanco. Okay. Optiflex is ractopamine hydrochloride. So Optiflex 45 contains 45.4 grams of ractopamine hydrochloride per pound of type A medicament. Okay. Actigain is marketed by Zoetis, and it's a synthetic, or not a synthetic, what is the generic? It's a generic version of ractopamine hydrochloride. Okay. So this is labeled to be fed the last 28 to 42 days. Most people are feeding it somewhere around the last 35 days on feed. Okay. We'll go more into what beta agonists do, their modes of action, and their impacts on performance on Thursday. Hopefully Kyle does a good job. Okay. By feeding it less than the upper limit of what it's labeled to be fed at, 42, by feeding it for 35 days, it gives you a week of wiggle room to get those cattle marketed. Okay. If I wanted to feed it right at 42 days, I would have to make dang sure I can send them to the packer on 42. Otherwise, these animals would be illegal. Okay. It is labeled to be fed or included in the type C feed at 9.8 to 24.6 grams per ton of 90% dry, so air dry. So that is equal to 10.9 to 27.33 grams per ton on a dry matter basis. Okay. It is labeled to be fed to animals at 90 to 430 milligrams per head per day. Okay. Most try to target that 300 milligrams per head per day. Experior is the most recent, the newest beta ligand. It is 1% active ingredient. So the type A is 1% active ingredient. The lubavergon is the active compound. Okay. So that type A is called Experior 10. Okay. It is labeled to be fed the last 14 to 91 days on feed. That's one heck of a window. Most people are feeding their dairy cattle, dairy-derived cattle, or heifers for 28 days. Most people are feeding their higher quality beef genetic cattle for 35 to 45 days. Okay. Inclusion is on label to be fed between 1.25 to 4.54 grams per ton of 90% dry matter. So that is equal to 1.39 to 5.04 grams of lubavergon per ton on a dry matter basis. You are labeled to feed 13 to 90 milligrams per head per day. Most people are feeding it at 36 milligrams per head per day. Okay. So everything I just said about Optiflex and building yourself some flexibility on the marketing window for live cattle by feeding under the 42 days, you have one heck of a wiggle room to market cattle when you have a 14 to 91 days on feed window. Okay. And I think on Thursday, Kyle should tell you why the FDA has allowed it to be fed for so long. Basically, most other beta adrenergic receptors on the cell will internalize after it's bound to. So once it gets bound to once, that receptor is no longer available to be bound to again and cause subsequent effects. However, lubavergon does not cause the beta-3 receptors to internalize, so they don't ever really adapt to that compound. It stays effective for longer, is the theory. However, most people still aren't feeding it 90 days. That's ridiculous.
Is this still similar to like confidence in this to it? As far as I know it's different, but like
Beta agonists are a heck of a drug. So I've compiled either from meta-analysis or for Experior, there's only like 7 studies. So I compiled all the data on them. So what they do is they bind to a receptor, they cause and antagonistic. So when I would say antagonistic effect, that means it binds to the receptor and makes it inactive, or an agonistic effect, which means it binds to the receptor and causes an action. Okay, so Optiflex is agonistic to beta 1 and 2 receptors. Lubavergon is antagonistic to beta 1, I think, and agonistic to beta 3. Okay, so once it binds to that receptor, it causes transcription things to happen to where enzymes get upregulated that promote protein accretion, downregulates protein degradation, and Optiflex will cause some fat mobilization. Okay, so what it's basically doing is shifting that growth curve of those fat animals, those animals in the last X number of days on feed, right? So it's making them leaner, and you'll actually see, I think Experior is somewhere around 34 pounds of additional hot carcass weight, but you'll reduce the percent that are breeding choice. You'll reduce back fat thickness, marbling score, all that stuff.
I just meant like as far as overdoing it, like how on that end.
Yeah, I see what you're saying. So most people are feeding that 36 milligrams of Experior because they don't see a benefit of feeding over that. So it's labeled to be fed up to what, 90 milligrams per head. Most people have not seen an additional benefit of going over 36. Yeah. If you are illegal on Experior, you're wasting a lot of money too. Yeah. Cool. Okay. Ad packs. All right. So ad packs, they're an additional supplement that people will buy when they don't have the micro machine or they're a small feedlot. Okay. So these ad packs will contain their type B medicated feed. They will contain whatever active ingredient you're trying to carry, and then they'll be diluted out using some kind of carrier. Could be distillers grains, soy hulls, whatever. Okay. So typically they're provided into the mixer to deliver X pounds of this ad pack per head per day. So you make your feed call, you have the amount of feed that you want to deliver to each pen, and then let's say you have 100 head, you want to provide 0.3 pounds per day of this ad pack, so 100 times 0.3 is 30 pounds. Into that mixer with all the rest of the ingredients, you would add 30 pounds of ad pack. And then you mix it and deliver that load, okay? So if you have 24,000 pound mixer on an ASFED basis, that's 18,000 pounds dry matter. We're assuming 75% dry. So that will feed 818 head of cattle if they're eating 22 pounds of dry matter intake a day. Okay. So if we want to add the ad pack at 0.3 pounds per head per day, then 818 times 0.3, that would be 245 pounds of this ad pack into that load. Make sense? Okay. Typically used in smaller feedlots that can't afford a micro machine, okay, will have a common monensin containing mineral that gets fed to all animals. Now, the only thing they'll have ad packs for are the special cases. So MGA to heifers, beta agonists to cattle that are on the last X number of days on feed. Does that make sense? So most big feed yards won't do an ad pack because they can provide these to specific loads using their micro machine. So these are bought prepackaged. They won't be made in-house. Okay. So one example of a type B medicated feed that's intended for an ad pack is Experior 240. There's 240 grams of flubavergon per ton. Okay. So 240 grams divided by 2,000 pounds. That is 0.012 grams of flubavergon per pound of ad pack times 1,000. That's 120 milligrams of flubavergon per pound. So if I want to feed 36 milligrams of flubavergon per head per day, how much ad pack should I feed per day? and we set up our units. I'm wanting 36 milligrams per head per day. I have 120 milligrams of lubavergon per pound. How many pounds of exterior 240 do I need to feed per head per day? Ben, you already got it. 0.3 pounds a head a day.
Yeah.
Okay. What'd you do?
36 divided by 120.
Okay. Wanting to bring 36, you know, that 120 per pound. So 36 divided by 120. Cancels out our milligrams of lubavergon, gives us pounds of Experior 240. Okay, simple enough. Okay. Okay, so there's the answer. Okay, so I think I mentioned some of this. There's some practical advantages for smaller feedlots on using ad packs. So you don't have to store many different premixes. Okay, you can just have one common premix, which will contain Maninsin, and then all of your other medicated feeds you can just bring into your ad pack. So you don't need a Maninsin supplement with and without beta agonists, for example. That should be beta ligands. Especially this is important if you're only going to feed that beta agonist, that beta ligand, for just a short period of time at the end of the feeding period. Okay. Another example of its benefits is Rumensin is labeled to be fed with Heifermax. Okay. However, they messed up on their FDA approval so that in the type B medicated feed inclusions they put there, it ends up not delivering enough drug to be legal to feed the type C medicated. So they messed up when they entered in, they ended up putting the type C medicated concentrations for the type B concentrations on the label. So they can be fed together legally in a type C ration. However, you can't mix a type B ration to provide those at legal limits. Okay? So you can use ad packs to get around this. You can use a ad pack with MGA and your common Rumensin premix, containing premix. So this isn't a concern for large feedlots where they're delivering these ingredients by skipping a type B, right? They're going right from a micro machine, which only has type A's, and then delivering it directly into their type C medicated feed. Does that make sense? Okay. Allows you to build flexibility in your target milligrams per head per day range. So as dry matter intake gets up, you're still only providing 0.3 pounds of Experior 240 per head per day to meet that 36 milligrams per head per day dose. Okay. So if that was in a premix, a type B medicated premix, you would be on average at 36 milligrams per head per day. But at the start, you're underfeeding. At the end, you're overfeeding as intake increases. We talked about that some. Okay, so this is our first lab example. We have 30 minutes. Who wants to run through it together? Okay. Who has their computers? Okay. Why don't I give you guys 15 minutes to work on this by yourselves, and then we'll work on it together. Or you can leave if you want. Up to you.
What is it like?
What is what? 90.7 grams of rumensin per pound of rumensin. I give you a lot of range there, and could just do the same one we already did, but you guys should get some practice.